This Week in Radio Tech, episode 152, is brought to you by Telos and the new HX6 six-line talk show system. The HX6 features 6 phone lines, 2 Telos hybrids, Omnia audio processing, and free call screening software. On the web at telos-systems.com/HX6.
And now, our feature presentation.
Twert.
Mixing pro, semi-pro, and home audio gear is challenging. We'll sort through audio hookups on this home studio boot camp.
All right, calm down. He says that to everyone.
This calls for immediate discussion.
What's up, Dad?
All your days are belong to us.
From his palatial office of important business,
or in a choice hotel in a distant land,
this is Kirk Harnack.
Chris Tobin joins me, plus Andrew Zarian jumps in to ask the questions that we thought y'all knew the answers to.
You're dialed in to This Week in Radio Tech.
Hi, it's time for This Week in Radio Tech. Twert, as we call it. This is episode number 152. Goodness, we've been doing this thing for almost 3 years. I'm Kirk Harnack, your host. I love talking about radio technology, and that's, the show's all about me and what I love to talk about. That's what we do, try to bring you some interesting topics, interesting guests. Heck, we've had Bob Orban on the show. We've had Greg Oganowski, Frank Foti, Steve Church has been on the show, Corny Gould, just lots of people, contract engineers, engineers from all over the world, including Igor Zucchina from Auckland, New Zealand, and we've just done a lot of good things. Well, we're going to give you a show tonight on this episode that speaks to a lot of basics about wiring a home studio. Folks have been asking for more information about this. So if you're an old hand at wiring studios, you may not hear any new information on this episode. But if you're interested in building a home studio or getting rid of a problem maybe that you have with your home studio or podcast studio, well, maybe you got a little corporate studio that you do podcasts with, or get the CEO to make appearances and sound bites with. Well, this is the show for you. We're going to talk about that. My co-host on the show is the best-dressed engineer in radio. It's Chris Tobin from Manhattan, New York. Hey, Chris.
Hello, Kirk. Yes, it's going to be a good show. We're going to have some good times, and building home studios and God knows what, and even professional studios. It's good stuff. So yeah, I'm with the folks at Music Cam USA. We do IP codecs, video and audio for disclosure for all of our audience. And the great part about Twert is it's filmed in front of a live studio. No, actually, network audience. It's everyone on the other side of the network.
That's right. That's right. All right. Well, hey, I brought a few props along. Oh, by the way, our show is going to be brought to you by the folks at Telos and the new HX6, which is a 6-line talk show system. It's great for music stations to take requests. It's great for news stations that don't want any more than 6 lines. You can put up to 8 controllers on it. It works with it comes with a free call screening system. So we'll talk about that halfway through the show. The Telos HX6. All right. So building a small studio. Probably one of the most popular audio consoles for a home or podcast studio is one made by Mackie. It's very high quality, despite the fact that it's not terribly expensive. And you can buy cheaper consoles, and you can buy more expensive consoles. But the audio console is so often the heart of what you need to do. And Andrew probably has a shot of this console available right now. It's the Mackie VLZ, or the 1402 VLZ. Does the VLZ come as a suffix or a prefix? Which is it? Oh, it's a suffix. It's 1402 VLZ3, so the third version. VLZ means what? Very low Z? Very low noise?
It's a low noise preamp, mic preamp. It's the original was a 1402, and then the mic preamps tend to be a little noisy, so the newer, very low noise mics were the VLZs.
Kirk, I thought it was low in zinc. I thought that's what it meant.
Very low zinc, yes.
It could be low in zinc to meet the environmental requirements these days.
By the way, if you're one of those people who actually reads a manual, you will get a kick out of Mackie manuals. They have some funny manual writers. Look at the schematic. It's pretty hilarious because there are a few things on the schematic that probably don't exist in the console itself. Like, Bob's house for the party is right here at the corner of these 2 wires. So we'll talk about the wiring a Mackie 1402 VLZ to various things that you might hook up to it. In fact, Andrew, go ahead and get a shot of that console back on there. And we zoomed in a bit on the audio connectors, because that's what we'll focus on. But you should know that to the lower part of the screen, that's just off the screen, are the faders for each channel strip. Now you see the knobs there are arranged in vertical rows. The red knobs are for what we call auxiliary sends. We'll explain that in a little while. The blue knobs are equalization, EQ, for each channel. And just below that, just out of sight, are the vertical faders. Those are the ones that you're going to be operating when you use the console. Those are the ones you're going to touch the most. But and each of these vertical strips we generally call a channel strip. Each one is a channel on the console. Each one is an input. On most consoles, most inexpensive consoles, each of these will be monaural, and you can pan the audio to the left or to the right or somewhere in the middle or anywhere you like between full left and full right. Normally, you keep for podcasts, you'd keep these in the middle, but you can pan them left and right. So at the top of each channel strip, these are where the audio input and output connectors are. And on a console, that's as flexible as something like a Mackie or many of the Behringer consoles and other ones too. These they give you a variety of different input connectors to use, and you'll see those on the first 6 channels on the upper left part of the screen. You'll see an XLR connector. It's female. That means it's going to be accepting audio coming into it. There's also a 1/4 inch. We tend to call them 1/4 inch connectors or 1/4 inch tip ring sleeve or TRS connectors. There's different names for them. And then there's each one of those has a little gray button by it. Andrew, can you see that? Is that a phantom power on each individual one? What is the gray button that's right next to the line and inputs? Anybody know?
I think it's a low pass filter.
Oh, yes. Okay, we'll explain that. A low pass filter. That's. Are you sure that's not down farther on the low pass? Is not farther in the EQ area?
I'm gonna go right over and look at it.
Talking about the tip ring sleeve, the little gray square button.
You're talking about these, right? Like right here.
The gray rectangular buttons that are up high next to the white knobs.
Low cut.
Oh, it's a low. It is low cut.
Yeah.
Well, a low cut button is typically used when you have a problem with wind noise, or you have a talent that's particularly windy or is popping his peas a whole lot in the microphone. A low cut button is like just an equalizer that gets rid of lower frequencies. Typically, everything below 80 hertz or 100 hertz or 50 hertz, a low cut filter will, and if there's wind noise across the microphone, like at an outdoor event, this will really cut down on the wind noise. And the white knobs, one on each of the first 6 channel strips, that is a gain trim, but it's actually a very wide-ranging gain trim. It'll allow you to put a higher level line level input into that channel, or you can crank it way up for a mic level input. And maybe you've got kind of a microphone that doesn't put out much. You can crank it way on up, or you got a microphone that puts out a lot of voltage for a given amount of sound pressure. You can turn it down a bit. So that's what the white knobs are. So that's kind of the input channels and the input connectors there. On that console, you've got XLRs for mics, and you've got they want you to use the tip ring sleeve connector, the 1/4 inch, for line level stuff. And if I'm not mistaken, most manufacturers arrange those tip ring sleeve connectors such that you can run either with a balanced connection going into it or an unbalanced connection. And I'll see if I can show you a little bit about that. Here is, if my camera will focus on it, this is actually an adapter, but if you had a cable with a tip ring sleeve connector on it, it would look like this. And on headphones, what you've got is you've got left and right and ground. Left is tip, right is the ring, and the sleeve is the ground. Well, those would be unbalanced, stereo unbalanced. On this console, the idea is that you're going to wire your input connectors. If you've got a balanced device, and we'll have to explain that, if you've got a balanced device feeding into it, then you're going to have plus and minus, or minus and plus, however they want it, and ground. So it's going to be a balanced connection with the tip and the ring, and then the sleeve will be ground. But if you have an unbalanced source, then you might have a connector that is just the tip and the sleeve. There'll be no ring. It'll just be solid metal back here after the first insulator. And then you'll have, so that'll be wired such that your signal or plus is on the tip, and then your ground is on the rest of it. So most consoles like this one will accept either a balanced or an unbalanced connection, and they'll do pretty well with either one. Let's see.
Well, there's also other stuff when you're doing balanced, unbalanced you got to be aware of, especially with the Mackie consoles and some of the newer stuff. As you were mentioning, the balanced, unbalanced, and the different pinouts, you know, the rings, tip ring, sleeve. Some of the older, not older, some mixer designs have a transformer input, so you don't realize it, but you can get away with a lot of little shortcuts with the unbalanced stuff.
Oh, that's right, yeah.
Balanced. And what happens is you get confused. Because you say, well, it worked for me the other day when I did this particular, I'll call it a contraption, thermostat connection between two devices. But then all of a sudden, a week later, a friend comes by and says, hey, let's do something with the studio. I got to decide a new music track for the group. And you plug the cable in and suddenly there's buzz. And you're like, wait a minute, what happened? What we changed? You just know that the input is either transformer input, which will tend to get rid of a lot of the buzzing by design, or what they call direct coupled, or DC for direct coupled, meaning that connector you're plugged into, the tip ring sleeve or the XLR 3 pin, goes from your device directly into electronics. So there's no transformer. Now remember, a transformer is a device that can come in various sizes. Transformers are in everything. It's just the way they're designed. So basically, if you can picture a square, take a square, just a square like a picture frame. Take out the inside of the picture frame. Now you have that outer frame. Now a transformer, to create a transformer, if you hold the frame vertical, on the left side of the frame, wrap around, say, a couple of dozen, wrap wire around a couple of times to make loops. And then you have two wires sticking out from that. You could do it 100 times, 1,000 times, or 2 times. Now the right side, you do the same thing. Now the picture frame that I'm talking about is made of metal, so it's an iron core. You've now created a transformer. Did you notice one thing? There's no direct connection between the left side and the right side.
That's right.
So therefore, there's no chance, or I will say a minimal chance, of hum or buzz or clicks and pops, because you are physically, electrically isolated from the circuit design of the mixer. Now, let's remove that picture frame square transformer and take your connector and plug it directly into electronics. Now what do you have? The outside world talking to the inside world of the mixer. And that's when you run into those wacky sounds. You've been at the clubs, you've heard the folks get on stage, they plug into something, and all of a sudden there's that wonderful sound that either pierces the ears, or shrapnel from a woofer or a tweeter comes flying out of the Marshall amp, and all of a sudden you've got a crazy distorted sound that's great for the music moment, but was the worst thing you could ever do. And that's part of it. That's why a lot of folks do field work with mixers that have transformers sticking on the outside of them. And there are a couple of companies that made some very, very high-quality transformers, so they almost emulate direct coupled input. Jensen is one of them.
Those are all very good points. And in fact, if you happen to have a console that does not have transformer balanced inputs, and they would be more expensive, and in many situations, transformer coupled or transformer balanced might be thought of as undesirable, because you can lose something in the process of a transformer as opposed to a circuit that's direct coupled.
Well, if you use a good transformer, though, you could get real close.
Exactly. And for example, if you want to, in radio stations, oftentimes we wanted to take a speakerphone output, so we tap across the speaker. We take the phone apart, tap across the speaker, and put a cheap little Radio Shack transformer in there, and then bring that out to a connector on the back of the phone, and then run that to the audio console. Now you have whatever happens on the speaker of the speakerphone, you will get an audio output of that. It's isolated, so there's no hum, no buzz. You're not connected to the power supply of the phone system or the rest of the phone company. You are isolated by a transformer, and then you have this nice isolated feed available for your audio console. That's just one possible way to use a transformer. Got a couple of questions out of the chat room that are probably worth talking about right at this point. Bob Holowenko says, hey, mention the difference between a balanced tip ring sleeve and a stereo unbalanced. I did touch on that briefly. I don't know when my camera or my feed locked up, but a balanced feed on a 1/4-inch tip ring sleeve, again, will have plus, minus, and ground. So you'll have plus and minus here. You actually don't have to have the ground. Balance, plus, and minus, is on its own a balanced signal. Every Cat5 Ethernet connection is balanced. You've got 2 wires for transmit and 2 for receive on a 100 megabit or 10 megabit circuit. And so this is balanced. And you notice most of the time there's no shield wire on this, and it works just fine. The other possibility is to have unbalanced, like stereo headphones, as I mentioned, where you have left and right and ground. So each of those is actually unbalanced. So the audio going to virtually any stereo headphones is unbalanced from the amp into your headphones. Now that's okay because a headphone feed is going to be kind of a high level. It's going to be fairly immune from nearby generators of hum and other noise. So unbalanced tends to work okay for something like headphones. The other thing to talk about is on these consoles, oftentimes you'll have a 1/4-inch connector that's called an insert point. And what is an insert point? Yeah, it can be. An insert point is a place where it's typically after the preamp in the console. So let's say you've got an instrument level input or a mic level input going in, and you want to use the preamp that's built into the console to preamplify whatever the low level device you're bringing in. But then you want to do some audio processing to it. Maybe you want to have a mic processor or some kind of a wah-wah or fuzz box or something like that. Well, the insert point lets you use a tip ring sleeve connector like this. And the tip is typically the output of the console, the insert point's output. So you're going to bring that out to your external device. And the ring is typically the return back in. And they design the plug such that if you don't plug anything into it, the insert point just shorts across itself, and so you go from the mic preamp on into the rest of the console. But if you insert a jack into it, a plug into the jack, it breaks that mechanical contact and makes the audio no longer go straight through. It comes out through the tip and returns through the ring out to whatever device you have. Now, that means that it's unbalanced going out. By the way, a good rule of thumb, unbalanced devices, unbalanced cabling, you don't want to run that audio very far. You don't want a 100-foot unbalanced cable. You don't even want a 20-foot unbalanced cable if you can help it. Unbalanced is okay for short runs. You know those 3-foot or 6-foot RCA patch cords that come with a new, dating myself, a new VCR, a DVD player? I think I bought a Blu-ray player just last week, and it came with actually some RCA patch cable. That's about as long as you ought to go. Chris, you got a comment or a rule of thumb about balanced and unbalanced RCA type plugs?
Yeah. Well, first things, if you build a home studio, all right, whatever your application may be, whether it's for music, for netcasting, whatever it is, if you can do balanced audio, just stick to balanced audio throughout. That'll save you a lot of headaches. Second, if you have to go with unbalanced, there are several rules of thumb. It's not easy to cover in this particular podcast, but just minimize the cable length. Remember this, balanced cables are less susceptible to noise generated by devices like cell phones, two-way radios, electric dimmers, light dimmers, CFL lights. Unbalanced is not. Unbalanced is more of like an antenna and says, oh, look, there's noise out there. Let me pick it up and bring it along to the amplifier I'm connected to. So try and keep it short, as Kirk pointed out. That's the best rule of thumb. Also a note with the insert points on a console, a mixer, whatever you want to call it, or desk if you're in the UK. Bear in mind those insert points are typically -10 or lower in level. There's the difference in levels in the studio. We have what you'll hear people talk about: professional level, consumer level, prosumer level. So I'll just do 3 numbers: +4 dB, 0 dB, and -10 dB. So -10 dB is what everybody pretty much is accustomed to. You don't even realize it, but you do when you see an RCA jack on the back of a device. Say your television has an output for your amplifier, if you want, for your home system. Typically, it's an RCA jack. It's white and red, red for right, white for left. That's -10. Okay? Those insert points are -10. But now, as Kirk pointed out, you said, I want to do a processor for my microphone. I want to sound like the voice of God or whatever, or Darth Vader. 10-to-1 odds, the output of that mic processing device is probably line level, which would be that higher number, +4. So do the math. -10, very low. So you got this low level here, high level up top, and you try to put it in, end result, very bad sound. So just understand and read through the book whether the Mackie mixer or whomever you use, whatever mixer you decide to go with. In those manuals, you'll find, and even in those mic processor books, usually a section on the difference between high level, low level, unbalanced, balanced. Understanding those little details and follow those rules of thumb, and you're in good shape.
Hey, Kirk, I got a question for you.
Yeah.
So when we tore apart the studio here, we had like 50-foot and 25-foot RCAs going into this Mackie.
Yeah.
And we were, using these kind of adapters and connecting to it. What are some problems that someone could encounter if they're using, long, I guess, anything over like 6 feet of RCAs for their studio and they're using unbalanced cables?
Well, I will say that you were actually doing a couple things right that minimized your problems with long RCA cables. First of all, the cables were really long, but you really didn't need cables that long. It wasn't all that far from one to the other, from one device to the other. You didn't need a 50-foot cable. It's just that's what you bought, and so a lot of it was wrapped up somewhere. And I'm not saying that's a good thing, but my point is this. It seems that all or most of the audio gear in your studio, which is in a fairly small room, was probably all plugged into the same outlet or same circuit.
Yes.
And so that actually helped minimize hum problems because it was all plugged into the same circuit from your electrical panel. And so that helps things out. If you got an unbalanced connection between devices that are plugged into, that are powered by different circuits, you got a lot more chance of a ground loop going on between those two things. And a ground loop is where you have hum current, you have AC current flowing through the ground side of an unbalanced wire, and that will induce a hum into into your audio that you certainly don't want. So the long cables that you had were actually very expensive and good cables. So, we pulled out quite a few cables, and those were some expensive, good cables that you had there. So I'm surprised they worked as well as they did, but glad they did.
Yeah, ground loop issues, the hum that you're talking about is a problem that plagues, internet broadcasters and podcasters. So many shows that I'm listening to, and every time they're playing a clip from their computer or they're playing it from some sort of device, there's an awful hum to it. And even with ground loop isolators, it's sometimes still there.
Yeah, and this is often a problem just in home wiring, not really realizing what you're plugging into or plugging into several different outlets in the room, and just miswiring, not understanding how the wiring works. Also, the cheap sound card that comes part of a computer, whether it's a laptop or a desktop type computer, you're never, and we've proved it at your studio, you're never going to get as good audio as you can in and out of that little 1/8-inch stereo jack, especially the horrible mic preamps that are in those things. So if you're doing a podcast or you're trying to record some audio by taking a mic and going into the mic, the little red ringed input on a laptop or on a desktop computer, I'm sorry, you're never going to be satisfied with that level of audio, that quality of audio. They have less than 1 penny worth of parts in that mic pre-input. It's just really bad. And even if you externally amplify that to a line level and go into the unbalanced line level, a cheap sound card has got all kinds of other compromises in its design with regard to the A to D conversion, and then the sampling and the low pass filtering for anti-aliasing. There's a myriad of things that are going to prevent you from getting good audio out of any computer's built-in audio sound system. Now, output can be not so bad. If you're going to run some surround speakers from a Creative Labs, something like that, surround output, that can actually kind of be okay until the connectors get dirty. Then you got to play with those. But the inputs, just can't recommend them. Hey, a question worth asking, because I don't know if all these audio consoles that have insert points, and it's true, they are a lower level, like -10, and they're unbalanced. Wouldn't they be intended to be used with outboard gear that is also -10 and unbalanced? In broadcast, we tend to buy outboard gear that's +4 and balanced. So yes, that is a connection problem. But if you go to the music store or go to Sweetwater Sound or any of these big equipment stores, Guitar Center and such, don't you buy outboard gear that is also unbalanced and -10 or has those inputs and outputs available?
Typically, but a lot of stuff nowadays has zero dB outputs. Some of the place up into it, Sweetwater. I mean, not all of them, but you also got to bear in mind that with unbalanced cabling, and the hums and buzzes that Andrew is pointing out. A lot of it has to do with just, I guess the way to put it is just best practice with the equipment, as Kirk pointed out. With a computer, since everybody uses computers to interface to anything, the largest noise generator in a computer is that 2.3 gigahertz CPU. So onboard sound cards are sitting right on the same plane as the noise generator. So you're not going to get anything really worthwhile.
Yeah.
But then you still run into the risk. What's that?
No, go ahead. Finish up.
But you still run into the risk, as Kirk pointed out, the chipset or the parts count is very low, and the quality is never going to be the best. And also, you're dealing with mic level. Remember, mic level. I don't know what the best way to put this is, but mic level is around minus 60 dB down. So let's say if you can imagine this clapping is say 0, okay, reference level. I'm hearing you, you're hearing me just fine. Then the sound of a microphone input is actually about this low in comparison. So think of this: if I'm talking to you like this, and this is the level that you're getting, and all of a sudden you put something else in a little louder, like this, did I just pop your ear? That's the difference between minus 60 and basically minus 10 and 0 dB. So you got a mic input you're trying to do everything with, from mixing down your studio tracks, anything, whether it's video cast or music, whatever, into that little jack that's doing this exactly what it is expecting to hear and not really getting it right. So I hope that was a little easier to understand, because I've had a lot of folks ask me the question, what's the big deal? Why can't it work? And there's a big difference between mic level and line level.
And in fact, I think the difference may be huger than the analogy that you're presenting there. Mic level is millivolts coming at, like for example, this microphone. I'm using a Heil PR40. It's a dynamic mic. The audio signal that comes out of the XLR connector on this mic, the voltage there is only the voltage that's generated by sound pressure waves moving a diaphragm of wire, a coil of wire past a magnet. That's all. That it is millivolts coming out of there, as opposed to something louder would be, or somewhat higher in level would be, a guitar pickup. I think those typically are a bit higher in level. They're not quite mic level. They're, I think, what we typically call instrument level. And then there's line level. That is the volume that comes out of a piece of professional gear. Here's a Telos IQ6 phone system behind me here. It's going to put out a nominal +4 dBu. We typically measure in dBu or dBV nowadays instead of dBm. Maybe we'll explain that on a different show. And then in the days of analog audio at television stations, they typically referenced everything to +8, so is 4 dB hotter. Anyhow, in the chat room, they've been mentioning that, hey, a good alternative. Somebody said, well, just send Kirk a blank check for some audio over IP. No, you don't have to do that. You can get great audio if you carefully choose the audio input and output devices. If you get clean audio into your computer, into your applications like Adobe Audition or Pro Tools or Audacity, if you get good clean audio into that, you're home free. Those programs operate in the digital domain, and they're probably not going to screw up your audio at all. You just have to get clean audio into the computer, and a great way to do that is with an external USB device, USB sound card device. Several companies make these. In fact, in a few months, company I work for, Telos, is going to come out with a very inexpensive stereo input-output device that operates on USB. It also gives you GPIO closures. But right now, I'm talking to you. This mic sounds awfully clean, and it's going through $120 Shure X2U, which is a mic preamp on one side and a USB connection on the other side into the computer. And it's pretty clean. I mean, for a $120 device, it sounds really nice. The audio that I hear back also is just as clean as a whistle. So it's possible, certainly, to get an external sound card that's USB-based and run that into your computer. Now, there are cheap ones, and there are good ones. Andrew, you have some experience with a fairly cheap one, that little round white puck external sound device. What brand is that one?
It's by Griffin. It's called the iMic. It's about $20, and the reason why we got it is because the new MacBook Pros only have one line in. Yeah, and you could either do line in or line out. That's it. So we got this, and it totally eliminating any kind of ground loop, any kind of humming, and it's an amazing mic, and you could do either line level or mic level on it. It has a little switch on the side. Yeah.
But we did compare the sound of that to the sound of direct digital audio, and there was a degradation with that $20 external box.
Yeah, absolutely.
But it wasn't horrible. I mean, it was acceptable audio. I mean, I'm not sure I'd cut the new Taylor Swift album with it, but it was acceptable audio. And you can buy certainly $200 or $400 external sound card boxes that are USB based.
Amazingly, Kirk, I was getting better audio with this than I had a very expensive creative sound card in one of the computers here, and it was awful. I was getting awful quality in there. There was constantly a buzz or a hum coming in, and when I popped this thing in, this was giving me better audio. So you'd be surprised. I mean, sometimes it just, you're right. Sometimes the chips that they're using on these things are really cheap, and sometimes they work pretty well.
Well, if you can buy for $20,
you get what you pay for. You get what you pay for.
If you can buy for $20, you can be sure the factory cost was well under 10. You can be sure. So, okay, let's see. We've pretty well hacked to death the idea of balanced and unbalanced. I hope we've cleared that up to some degree. A few different connectors. One thing that I forgot to take this apart, and I should go ahead and do it. Here's a female XLR connector, right? And this is not a Neutrik or even a what was the other good brand? I forget. Switchcraft. Yeah, this one's a cheap one from Radio Shack, I think, or maybe MCM Electronics or who knows what. Anyway, it's not a great one.
Well, those are knockoffs.
Yeah, knockoff. That's true. But I wanted to point out, if you want to put one of these on, you have got to learn how to solder onto those little connectors there and not make solder bridges and make your connections good. You don't want to apply a whole lot of heat, just barely enough to get the solder melted onto there. And you've got to look very carefully as to which pin is which, so you get the right pins done here. This will be a balanced connector. It has, there's a high, low, and a ground, or you might say a plus, minus, and ground. And Chris, what is the rule of thumb for which pin is hot?
Well, in the United States, North America, pin 2 is hot, a high plus sign. Some folks, if you follow the traditional methods, it used to be pin 3, but pin 2 is high, pin 3 is the low side, so it's plus on 2, minus on 3, and then the ground or reference or return, earth, whatever you want to call it, would be on pin 1. So if you're doing an unbalanced connection from an XLR connector to a phone plug, you'd be using pins 2 and 1 in most cases, where pin 3 is left alone, because you don't want to short out the input on the device.
Oh, okay. I thought for if you're sending audio into something, that if you're using an unbalanced connector a balanced connector, but you've got an unbalanced audio wire going into it, you would want to short one of those pins to ground. The low pin would short to ground, and then pin 2 would be hot.
The problem you run into on some devices, it depends on the type of input. So, like if it's a servo balanced output or an input that's got 2 op amps and it's designed to operate in like a servo, where the high and low is flipping, then you can get away with that. In some devices, if you pin 3 to ground, it actually shorts out the power side of the input.
Oh, well,
the op amp, op amp is no longer functioning.
Gotcha. And also, the best rule of thumb, though, if you can't see the internal design, is if it's a balanced output, from a professional device, then you don't want to short any pins to ground. You're going to use ground. If you've got a balanced output and you're feeding it into an unbalanced input somewhere else, so let's say you got a professional console with a balanced output, and you want to feed it into a cassette recorder, to use an example here of something that's going to probably have an unbalanced input. You want to wire, the cassette's going to have, or the cheap input here. I'll use this. Here's a little monitor amplifier that I sometimes use because it sounds really good, and it has unbalanced inputs. Hope you can see that on the back. There's a couple of RCA connectors, and so if I want to wire a professional output into this thing, I'm going to ignore one of the outputs, unless of course it's a transformer output. Then I've got to use both outputs. But let's say it's a modern op amp output. I don't want to short either hot output, either the plus or the minus output. So I've got a plus, a minus, and a ground. I just want to wire one of those sides to the plus input on my unbalanced device, and then the ground will carry through from ground to ground. And normally that'll work. If it's a DC coupled or an op amp output from a modern audio console or other balanced device, that'll probably work fine. If it's a transformer output from some device, then half transformer doesn't work. You have to complete the circuit, in which case you would bridge the one side of the transformer output to ground, and that would carry over to ground on your input device, and then the other side of the transformer would carry to the hot input of your unbalanced device.
Right. So now the other thing you have to do though is you get yourself a cable tester.
Yeah. In fact, I brought some more show and tell here.
I have one I can show and tell also.
Yeah, go ahead. What you got?
If you want, I got this one. I've used this for years. It's the Swiss Army, I think it's called. EBTech makes it, and it's a pretty cool device. Let's see. You look at it carefully, you'll see the lights come on, and the lights here tell you the pinouts. Okay, so I'm using a tiny telephone. All right, it's tip ring sleeve. It's professional, and I'm taking the output of that because this is an output cable. Remember, male connector is outputs, female is the other one. I won't go into detail as to why it's that way. And then we take this male connector, place it into the female connector, which is right here. And then, hang on. So the lights don't make any sense at the moment. So we press the test cable button. Now the lights should appear in a straight line, as they do. That indicates pin 1 to pin 1, pin 2 to pin 2, and pin 3 to pin 3. Now I know the cable I've just made is correct. If the cable is incorrect and out of phase, which means pin 2 is connected to pin 3 at the other end, and pin, that whole stuff. Well, in stereo, you'll have a very wide left and right. In mono, odds are you won't be heard. So there's a good chance nobody will hear you on the internet when you're doing your podcast. So it's always good to have it. It's an inexpensive tester. The nice thing about this tester is it has the ability to do RCA plugs, tip ring sleeve here. Yeah. And the XLR. So basically all of your studio stuff. Oh, and let's not forget the 1/8 inch little mini plugs, as we all know them by. So this little guy does pretty well. And if you want to, you can also set up a test tone, and you can do a test tone at various levels. So you can do continuity testing. So it's a pretty handy little guy. So that's
what's the brand name of that one?
This one's called Swiss Army, SWIZ Army. But I believe it's ebtech.com. EBTech Audio, or ebtech.com. They're the ones that sell it. And it's a pretty handy little box. I've had it for years. This is the original one. The new one has a different logo on it. But it's pretty cool. I have been able to troubleshoot, do stuff within seconds when I get a phone call when I was working at a couple of radio stations where there was a studio issue. Like, I don't know what's going on, blah, blah, blah. Popped in, took the cables, plugged in, and said, hey, it's a problem, bad cable, moved it, and out within literally less than 5 minutes. Between that, and you can also use the Q box if you want to do Whirlwind, but there's plenty of other devices out there. And why this box is handy, if you really get creative, it has a built-in speaker. Okay, you're not going to hear this. But it has built-in speaker. It has the headphones jack, so you can listen to the source of the audio. And if you make yourself a nice little test cable with alligator clips, and you've probably seen these, you can attach these to different devices that you can't seem to get audio out of, or there's an issue. And with the built-in speaker, you don't have to worry about fumbling for headphones or finding the right ones and blasting out your ears. This also generates tones. And it has a built-in microphone. So you could actually talk into this device and down the line to whatever you're testing. So between those two devices, you can actually test out everything you need to do in your studio and have it ready when there's a problem. And much quicker than trying to figure out using God knows what you come up with.
Hey, Chris, I'm just curious. Do you recommend someone use something like Deoxit?
Deoxit for connectors that oxidize?
Yeah.
You can. There's Deoxit, there's Stabilent, there's a few others. If you have connectors oxidizing in your studio, two things to consider. One, the age of the connector. What's that?
Yeah. You might have other problems. Yeah.
Either that, either the age of the connector or the device, which, you may have inherited something from a friend. Say, hey, I got this nice DBX 140A. We've had it in our studios for 50 years. And yes, it's going to have probably oxidized connectors. Or you have a studio where you're doing a lot of smoking. If you do smoking, cigarette smoking, cigar smoking, though it may be it makes you happy and feel good, it is probably the worst thing for electronic equipment. I have worked in many a studio over the years where we were cleaning out equipment bays, and the nicotine tar actually eroded the solder connections and various other connection points. So keep that in mind. Also, if you have high humidity in the studios, in your office, or wherever you're building your place, if it's a basement, humidity is a disaster. So that too will oxidize and cause problems. So Deoxit works, Stabilent works. Just got to be careful when you try to clean the connectors. If you clean them too hard with a tool, there's special tools you can use, or too much of the solvent will actually wear away the chrome or silver plating of the connector, and then that'll create even more trouble for you. So you shouldn't have to be doing that. I mean, most people shouldn't have to do if you have equipment that's been purchased in the last year or two.
Now,
again,
Chris, you got all those fancy cable testers there. And I got to tell you, in my entire career from the age of 18 on to now, I have never owned a cable tester. I wish I had. Just never, whipped out the $35 to $300 that those things can cost. And
you can use a Simpson meter. I used to use a Simpson meter.
And I don't have a Simpson handy. I've got, let's see, this is, oh gosh, I think I paid $9.99 for this one. And
I have a Fluke DVM.
Well, I mean $9.99 for this one.
Now the thing is though, if you're gonna do something with a DVM, you want to make sure it's a true RMS.
Well, but not if you're just checking to see, do I have here's some headphones. These are noise canceling, but they work like regular headphones when they're not turned on. So we can get something here. So if you need to test something like headphones, here's the little 3.5 millimeter connector. And I'm going to, instead of using a fancy cable tester on this, I can just, I can pull it out. Here we go. So here we got a typical cable. All right. 3.5 millimeter tip ring sleeve or 1/8 inch tip ring sleeve on each end. So if I want to see, hey, is the ground good here? I'm going to hold this lead. I've got this thing in the ohms position. Ohm. In fact, I think I can put this on a position where it will make a noise if I...
It should have a little sound, yes.
It should. This one may not. It has a diode. Yeah, it's got a diode position. I don't see where it's going to make noise.
The little radio wave, the little waves. Oh, there you go. Yeah.
Well, okay. There we go. So it's showing what, 0 ohms? Yeah. So that's now. So here's ground at one end and ground at the other end, and you could test the ring side. So I'm saying you could test cables without a fancy cable tester if you know what you're doing. But holding two things at once like this is pretty difficult, and you got to be quick on the eye and quick on the hold. And anyway, it's my whole career. I was charging by the hour, so this is the way I did it. Okay,
that's a good way to do it. Well, I'm just showing up those little devices only because if you're going to make a living or try to do something with a home studio or a home network, whatever, and time is of the essence, and it's going to be time is money. Those little boxes, the two of them, and probably won't cost you that. I don't think it's that much. The Q box, well, that's Whirlwind. It might be a little expensive, but the Swiss Army I think was pretty cheap. That'll save you a lot of time and trouble. And unless you're right, if you use a DVM or a Simpson 260 analog meter and you know how to use it and read it, they're off to the races. I did that early on also. But I was just trying to offer up something for those who are just sort of in between.
Question has come up. Okay, so what's the cheap way to, if you got a +4 output that's balanced and you want to go to a -10 input that's unbalanced, what's the cheap way to do that? Well, you can, just build a cable with no attenuation, just a cable that's wired, as we said earlier, depending on the output circuit of the balanced. You can wire this directly. You're going to be putting a +4 into this -10. Now, perhaps you can turn down the +4 on the output of whatever device that you're sending audio out of, and maybe get down to close to -10. Maybe the audio input on the circuit that you're going into that's unbalanced won't mind a +4. Both of these are kind of shaky and often don't work. Here's an example. This is a totally passive. There's no attenuation here. Here's an adapter. I actually love these things because they do help out sometimes. It's RCA on one side, unbalanced, and XLR on the other side. You can get this, and you can get the opposite of this. You can get this into a female XLR. You can also get male RCA on this end for various adaptation. This came from Guitar Center here in Nashville. This can be a real lifesaver if you're trying to hook stuff up. But remember, the level and the balanced or unbalanced may be completely wrong for what you're trying to do. Some equipment won't mind this. Other equipment will mind this. The right way to get from balanced to unbalanced or unbalanced to balanced, and get the levels right and get the impedances right and get the number of wires in there right, is to use an active matching amplifier. The usual industry buzzword would be a matchbox, and that's also a brand name of the ones made by Henry Engineering. You can also, I think at Andrew, at your studio, we bought some. They're not Matchbox brand. There's some different ones. They were about $50 or less a piece. There you go. Oh, a Rolls. Okay. That's the cheap honking one I told you to buy, right?
That is.
And so on one side, you've got your RCAs, and on the other side, you've got your XLRs. And I think, did you pay, what, $50, $60 for those or less?
I think we ordered like 6 of them, and we paid $50.
$50 each.
Yeah. The great thing was it was on Amazon, so I was able to return them, but I kept 2 of them.
Okay, that's right. When I'm wiring a studio and I'm not really sure what I'm getting into, or I haven't documented everything, I'll order a few of those, because if all the AXIA gear that you've got is all balanced input and output. If it's not AES, if it's an analog I/O, then it's going to be balanced at +4. And if you want to connect to semi-pro electronic gear, you can waste half the day trying to build cables or solder some resistors in there to knock the level down if you got to do that, and it's just not worth it. I mean, your time is valuable. If I spend more than an hour fiddling with that, we could have bought a matchbox, and so we just buy RCA cables that are short. That matchbox thing goes close to the unbalanced device. And then the balanced cables can be much longer because they're balanced and at a higher level. They're more immune to hum and buzz and stuff. And you run that into and out of your balanced inputs and outputs. Since these boxes are no longer, these match boxes, you can pay $200 for them, but you can also buy them for $50 and under. The quality's probably not as good, but you know what? In most cases, they work fine. So
most of them are pretty decent.
Yeah. Yeah, well, and the electronics to do that is so simple nowadays. It's a few
another
chips.
method you could use. There's a passive method you could use from Sescom or Shure. Those XLR inline attenuateuators with this selectable.
Oh, that's
switch.
right. Yeah, XLR inline.
Here, I have one here that you can let's see if I pop. I hope it'll zoom in. In any case, this one is for a mic level to line level, so I can actually take a line level device and plug it into a mic input. And I've used this on many occasions with mic processors and USB mixers. Works out really well. It's a perfect match. It's balanced. Now, if you're talking about the unbalanced -10 to +4 that was mentioned in the chat room, you can also get what they have is a switchable type. And then there's a switch, 3-position switch. It's a yellow label from Shure Brothers. It's balanced, so you make yourself a balanced XLR to unbalanced cable, which is the RCA jack. And then you can select either 15 dB, 20 dB, or 25 dB attenuation. Typically, if you're going to go from -10 or +4, that's about a 14 to 15 dB difference in gain, so you could pop in a 20 dB attenuator and off to the races you go. But the nice thing about that is passive, and if you don't have the room for a active device, you can pop that into the rack or the cabinet that you have, and off you go. I've done that in a lot of places where friends of mine who do voice work have home studios and are very limited with space, but have a lot of -10 gear.
All right, we're going to continue with yapping about how to wire home studios and some of the real typical problems people run into, and how we try to solve those problems, either inexpensively or doing it right, and sometimes inexpensively can be doing it right. But for now, we're going to take a minute and talk about the sponsor of our show, and it happens to be my employer. Thank them very much for sponsoring the show. And that's the Telos Alliance. And on this show, I want to talk to you about a brand new phone system that Telos has come out with. It's a multi-line phone system. So it's perfect for radio stations, for podcasters who want to take phone calls and actually do a talk show format. It's the new Telos HX6, and it actually just started shipping finally this week. It's first of all, it's a 6-line phone system, so you can plug in up to 6 phone lines. These can be either POTS, ordinary analog phone lines. And by the way, your POTS connection, that can come from the phone company, of course, but you can do what some other folks do. You can get several Vonage boxes and come out of the POTS outputs of those, and basically pay less for a Vonage type service. You can use Magic Jack if you want to. You can use other voice over IP service providers and use their inexpensive ATAs, analog terminal adapters, to bring yourself some POTS lines. If you use a service like Vonage, they let you roll over to a different line if the first line is busy. So you can actually have a multi-line automatic rollover or hunt group phone system by using a service like Vonage, and others will help you get that done too. Magic Jack doesn't. So that's one way to get POTS lines. If you want to use ISDN lines, you can. You can get an ISDN module for the Telos HX6 and use ISDN lines. 3 ISDN circuits gives you 6 phone numbers for ISDN. Now, some other features. It has built into it, not one, but it has 2 telephone hybrids, and these are the best hybrids that Telos knows how to build. These have an extra long cancellation tail, if you will, that work great when the call is coming from a VoIP telephone, voice over IP, that has more delay, more latency. Also works great when the call is coming in from a cell phone connection, where there's more delay and more latency. So the hybrids also have automatic dynamic equalization. So they'll automatically EQ each call for you. There's also Omnia audio processing inside this box. So it'll hold the level of these callers. A low-level caller will get brought up. High-level callers will get put back down, so that all your callers should be about the same level. So 2 hybrids, 6 lines, and you can control it from a variety of different ways. There's actually a console module, an extension available for the Axia console that Andrew has at his studio that would allow him to control this phone system. Or you can use one of our VSET 6 phone controllers. Here's one right here. To control it. And these can go on a computer network if you want to. You can plug it in directly, or you can run it through an Ethernet switch and have several of them on the HX6. Folks, it sounds really, really good. That's what I want to say about the HX6, and it's very affordable. It's priced between the Telos 1X6 and the Telos NX6. So I really encourage you to take a look at the HX6 to do a multi-line phone system for your podcast or your broadcast facility, your radio station, your TV station, whatever you got. You can do a heck of a good talk show with the Telos HX6 shipping now. All right. Let's. Oh, I want to move on. I want to get this out of the way. One of the tools that I love to use for building a studio, especially when you've got multiple studios in different rooms. Maybe you got an equipment rack in one room and a studio in another room, and you need to find out, oh, does this wire really go over there? Well, a lot of folks call this a Fox and Hound. This part is the Fox, I guess. This is a tone generator. It can make a steady tone or a warble tone. I think you can set that inside. It can also tell you about continuity, I believe. Are the batteries in this thing any good? Oh, yeah, they are. Okay. So it has, by the way, it's useful for telephone lines, pre-wired installation, so it's got an RJ jack on there to plug in a phone jack, but it's also got alligator clips. And there's
just
an LED on
careful when you use
there.
it for continuity, though.
Why is that?
Because it's about 9 volts coming out.
Yeah, you might plug it into. Oh, it is. It's a higher voltage, huh? So there you go.
Yeah, if you're going across a pair of wires you think are not terminated to a device, you may put 9 volts into that device. If it's a mic preamp.
Okay, gotcha. Yeah, and you know what? I knew that, but I would never think of to tell somebody that. Indeed, that's true. Don't plug this across for continuity if you think there is a piece of equipment on the other end, because it is 9 volts. It's plenty there. You can also put this thing, there's a continuity, the switch is 3 positions. Middle is off. That way is for continuity. This way, it puts out a tone. And so here's the sniffer. And did I tell you right or wrong? Okay, oh, maybe I need to turn it. There we go. Okay. So this has a button on it, and it has an inductive pickup right here. So you can just really hear it going. I'll turn it off here. See, this has a lot of gain. You hold it up next to something, get a lot of gain. Just touch it with your finger, you change it. But you can do a lot of troubleshooting. In fact, if you're trying to find, I know that my ABC radio news feed is on here somewhere. You can go up and down a punch block and find it. You can just, go through wires, and wherever it seems to be the loudest, you can hunt down the wire that it's on. Or you can also, there's the wire. So you can see that this can be pretty useful. I have just used so much of these. They're just very, very helpful. Chris, you ever use one of these?
Absolutely. I have one in my tool bag. I have that and a butt set, or the telephone test set that goes with it. I've used those. Got all kinds of tools, little gadgets and stuff. Even also another handy device to have when you're working in a home studio that you're building or futzing around, and we all know there's plenty of cables to be had, whether it be in the bedroom, the kitchen, or basement that you're doing in the attic, is an AC voltage detector. It seems like a goofy thing, but why would I care? Believe it or not, it's very possible you may think some device is not plugged in or energized, and then you go to do something and you put your hands on the wires, and before you know it, you're flying across the room or doing a dance that nobody else would ever want to try and do with you. So
how about that? I've got one. I got one right here too. It's a little bit different than yours, but does the same thing.
Well, they come in various types and sizes.
Yeah.
So the
lights
nice
up when
thing
it gets
is,
close to AC.
what's really cool is if you're on a plugs, here's a power strip, right? There's a little utility strip, and there's 2 sizes to the blades. There's the larger blade and the smaller blade. It's polarized because you have neutral and you have the high side of an AC line. So the nice thing is with these detectors is if you plug it in, and if you can see the light flashing or you can hear it, That's telling me I'm on the high side, or what to believe the black wire in electrical terms. And then the other side, which is the larger blade, which is neutral, it should have no current on it. It's quiet. There's nothing. No lights, no sounds. It's handy. Also, if you're not able to get to the plug side, okay, if you just take the device and then run it along the wire, if there's any leakage, it'll be detected. If not, then you're okay. It only works with AC. If you have a DC output, you're not going to hear anything. So the nice thing is, at least if you come across a wire that starts to make this thing beep like so, oops, then you know there's a good chance there's a high voltage on there. I only say this because I worked in a facility once where someone decided to put 120 volts across what would appear to be standard audio cables.
Oh, I was just going to guess that. Oh, no.
Yes, and I will tell you that the diagonal cables, the diagonal cutters that I had did snap. There was a huge flash. I was in the base of the rack. So if you can picture an equipment rack, it's about 6 feet tall, about 20 inches wide, and you're inside it working, and suddenly there's a flash of light from an electrical short, and you're holding the device that's causing the short. Just imagine what it feels like ramming your back against the door and then against the wall. So it's handy to have. It's a device you should definitely keep with you when you're doing work in your studio and whatnot. And just probe around. Very handy.
Why is it, Chris, that most contract engineers I know, maybe I should say those who are our age, have a story about a studio or a transmitter site where they cut an audio wire like good old Belden 8451 or 9451, and the exact same thing happens, and there's 110 volts on it. What is up with that?
I think that's because back in the day, you have to remember the old phone systems, the 1A2, the key sets, the push buttons, those white clear, and the clear buttons with the white, and the red one is for hold. The ringing voltage on those was 90 volts. So a lot of folks figured if I can put 90 volts ringing voltage on a twisted pair of 25 pair cable, why not put 120 volts? It's AC. It's the same thing. That's my guess, because that's where I found all these issues with either 25 pair phone cable energized or Belden 8051.
And the other thing that may have led to this is back in the day, many transmitters used 110 volts as their external control, on, off, instead of 24 volts or 12 volts like they do now. Or
an audio rack, you wouldn't expect that.
Yeah. But if you wire from the transmitter to the remote control unit, and you didn't use an external relay to change that, you might well have 110 volts on. Well, it's just going to be on this one thing, Okay.
Yeah, absolutely.
And I know about it. I'll be the engineer here forever. Something else I like, one of the first troubleshooting, when I was a contract engineer for quite a few years, and then I went to work for Scott Studios in Dallas. And one of my first things I was sent out on was a job to figure out why is this station's computer network not working. And this was back in the day when we did networking with thin Ethernet, right? So different rooms were all hooked together with thin Ethernet, and it wasn't communicating. Well, I started, divide and conquer, pulling this Ethernet apart, and I pulled two apart, and I got the shock of my life. But by touching two ends of the outside, of these BNC cables, the BNC connectors, I thought, must be some AC leakage here somewhere. I wonder if all the plugs are wired correctly. I think I've told the story on a War Stories episode. Well, I wanted to have a quick and easy test. I had a lot of outlets to check and see where there may be a miswiring. So I went down to the local Walmart and I bought one of these AC testers. Okay, you plug it in the wall and it lights up in the correct pattern to tell you if it's wired correctly. And there's a little chart on there that tells you, hey, if it's wired correctly or if there's been a reversal of the the ground, the neutral, the hot, whatever. Well, I found that in the addition to the building, the studio building, all the outlets were swapped for hot and neutral. And that was causing leakage through the computer cases, I suppose. And anyway, putting 110 volts at a fairly low current, but nonetheless enough to shock you.
Well, you know what happened probably? Those cables, coax cables, ran along the BX or the onboard cable in the walls.
Ah, okay.
And the BNC connector didn't get insulated because it's it's metal, it's exposed, and then all it takes is one connection, one brushing up against that circuit. Could
have been that too. It could have been. I believe though there was leakage, and I believe that some of the computer cases were actually hot, but you never knew it because you weren't touching two things at once.
Oh wow, that's worse.
Because hot and neutral was reversed. But anyway, got that got that fixed. Thanks to this little device here, under $10, maybe $6 at Walmart and other hardware stores or electronic
That will also
stores.
help you in your home studio for audio noise issues.
Yeah, because there are plenty of homes. Maybe you've got an addition to your home, an outbuilding that you're going to use for your studio. Oftentimes, you're not in the main part of the home. Maybe you're like Andrew. You got a home that's 100 years old, and who knows how it's wired. Well, this guy right here will help you out.
That's cloth wiring.
Yeah, posting. Yeah. Oh golly, I'm sure there's plenty of things we haven't covered yet. We're about out of time. We ought to try to cover at least a few more things. Hey, Andrew, can you put that camera back on the Mackie console? We ought to cover a few more connections that are on there. Is that a possibility?
Yep, got it up and running.
All right. Well, I want to mention we've talked about those inputs, the mic level and the on XLRs, the line level on 1/4-inch tip ring sleeves, those white knobs that are the trim level. And the way to adjust that trim is take the fader that's not on the picture here, but it's down below. Put the fader up where it should go, which is about 80% of the way up its travel on the vertical fader, the linear fader. Then look at the meters on the console and adjust the trim level so that where you've got the fader is the right place for it to be. Whenever you set up an audio system from end to end, source devices, a mixing console, and then on to end devices, you want every device in the system to be operating at its optimal audio level. You don't want a level to be really low somewhere just so you can crank it up somewhere else, okay? If you do that, you're going to end up with a higher noise floor than you want. You want every stage along the way, whether it's inside the console, outside the console, some piece of equipment here or there, you want it to operate at its normal operating level. You really don't want to find an input knob on some device somewhere that's just barely cracked open, because you're feeding it a really hot level of audio, and for the device to work right, you're just cracking the audio barely. By the way, you'll find that if you put hot audio into a computer card, for example. You're going to find that in your Windows mixer, you barely crack the audio open, and wham, that's all the level that you need. Folks, that's not optimal. You want to avoid that situation. You want controls to run, in the middle or about wherever you think the manufacturer designed that control to run. So, back to this idea. If you put the fader about 80% of the way, or oftentimes there's a mark there, maybe 10 dB below the top, maybe 15 dB below the top. It'll be marked with a thick mark. Put the fader there, plug the device in, run it at its normal level, and then adjust that trim control so that you've got the right level on the meters of the console. Did I get that right? Chris, any argument?
No argument. That's right. Most console manufacturers have a marker on the fader.
Yeah, you're right. So then the input level is probably about right if you're using the correct connector, and the gain structure inside there. That means the gain in the equalizer is also about right. If let's say you run an audio level in that's way too low and you're going to actually use some of the equalizer controls, turn them all up to make that level hotter, that's the wrong thing to do. You're going to get noise from that equalizer. Well, you see all kinds of things. So you want to run control. If a control's not running where it ought to run, kind of in the middle or maybe a little higher than the middle, you got to think, okay, there's a problem somewhere that I shouldn't solve just by barely cracking this fader or by running it all the way open. There's a problem that I should solve before this. Let's find out what it is. Maybe I've wired, if you've got a balanced connection and one of those two wires is broken or the connection's not made, or as we say, there's an air gap somewhere in that balanced wiring, you're probably going to have audio, but it's going to be at least 6 dB lower than it should be, and there may not be a lot of bass in that audio. It may be kind of tinny sounding. So if you ever connect something up, especially if you're connecting up stereo connections and you notice one channel is good and the other channel is exactly 6 dB lower, then probably you have a broken wire, a broken connection, a connection that's not making in one side of that stereo audio. So this is left and this is right. I guess to you, this is left and this is right. If one of those wires is broken or not making contact, that's exactly what you'll get. Good level, good bass, good highs on one channel, 6 dB lower, and little bass on the other channel, and maybe some hum too. So that's a great clue to look for, just a simple broken wire. Also, a good way to troubleshoot that is to just pull out left and right and swap them. and see, does the problem follow this, and at which end do I swap these cables? Does the problem follow? And that's a good way to help figure out, aha, must be this cable, or hey, maybe it's a bad output on a piece of gear or a bad input. Andrew, also on that mixer, I guess we should explain some of the stuff in the upper right-hand side. A lot of these mixers will have a grouping of 4 RCA connectors. Oftentimes, these are for what they call tape in and tape out. I'm not sure if that's the case on this particular console. Can you read that, Andrew, what it says around the 4 RCA connectors that are on there?
Yep, tape in and tape out.
Well, there you go. And the back of your home stereo system might have that as well. Chris, explain tape in, tape out, because I'll get it wrong.
Well, tape in, tape out actually goes back to if you're using a recording device and you want to record what's coming in and out of the mixer, you would tape the output of the mixer, okay, is tape out. Actually, it probably shouldn't say tape anymore. It should just say device out or something. But you take that output and put it to the input, say, of a reel-to-reel, open reel machine or a CD recorder. And then the output of that CD recorder would go to the tape in. And now you have yourself a device that you can record your audio from the console, and if you want, you can play back from that device into your console. There should be controls on the mixer for bringing back the tape level. That's it's probably the simplest, easiest way. I'm not sure how many people use it for that purpose anymore. I know a lot of folks that used to use the tape out as a way of recording as a safety. Everything that went through the mixer just went to those outputs, and they put a digital recorder, like a flash memory recorder on the side, and let it roll, so to speak. And that's the way they went with it.
Mike Phillips simplifies, and Mike is so good at this. He simplifies as to what it is. He reminds us that tape out is going to be the same as the main out, except it's unbalanced and minus 10 in level. The tape in, oftentimes there is a separate little pot, and maybe it's the case on this Mackie. There's a separate little, usually not one of the main faders, but a little rotary fader that will bring the tape, sometimes called tape return or just return or tape in, and will bring the output of a tape machine back into the main mix on a small console like this one. Hey, we should probably take a moment to explain aux 1 and aux 2. A lot of small consoles like this have an aux 1 bus and an aux 2 bus. And the whole purpose, well, a couple of different ways you can use the aux buses. You can use them as an effects send. Let's say that you want all the mics to get some reverb on them. So you could take aux 1 on each of your microphones. Let's say you got 4 mics plugged into this thing in channels 1, 2, 3, and 4. You could take aux 1 and turn them each up a certain amount, maybe halfway or so. In fact, these may have a detent at halfway up. And then there will be an aux 1 output on the console. So this will be a mix. No matter where you have the main faders, the individual channel faders, no matter where you have those, you'll get a pre-fader mix of whatever you've got turned up in aux 1. And so you can take this out to an effects device and then bring it back in. Oftentimes there's an effects return that you can then mix back in to your main mix. So that's one use of an aux mix bus or an aux send. You can, in broadcasting, we often use an aux bus to make ourselves a mix minus. So let's say that we have a telephone hybrid or a codec. We have some device that we got some guy on the other end, a caller, a reporter or something who's talking to us. We want to send audio back to that person, but we don't want to send that person's audio back to that person. Let's say we've got, let's say Andrew's doing a show. He's got a codec there or a phone hybrid, and I'm on the other end. And I'm talking to Andrew. I'm a caller. I'm talking to Andrew. He wants to mix me into the show. He wants me to hear the show. But I don't need to hear myself back because that's going to be a delay and it's going to be very confusing. So we want to send me a mix of the show minus myself, minus the thing that I'm coming in on. So mix minus. So on the aux bus, we could turn everything up, or everything that he wanted me to hear up, and take that output and send that to me, but not myself. He's going to keep me turned down. And this console has 2 aux buses, so you could create 2 mix minuses with this console and thereby have two phone callers, a phone caller and somebody on a codec, somebody on, who knows, a satellite link, a remote intercom, who knows, but two different people who you don't want to send themselves back to themselves, okay? But you can cross-connect them this way. So the guy on the phone can hear the guy on the codec and vice versa if you got the right knobs turned up in the mix-minus bus. Andrew doesn't have to worry about that because his console does all that automatically.
It does everything automatically. But Kirk, it's one of the most overlooked things in podcasting and in internet broadcasting. Yeah. People totally forget about mix minus because you're doing Skype and they do some sort of, echo cancellation and mix minus, but it's still not perfect at all. And Mike Phillips actually wrote an article about explaining aux send with mix minus, and it's a great explanation if anybody wants to learn a little more about it.
Hey, and Mike Phillips just reminded us, and this is great in the room right now, I'm hearing the show, but I'm not hearing myself come back from the studio. I'm hearing everything but myself. And the same for Chris Tobin. He's hearing me and Andrew, but he's not hearing himself being fed back to him. And that's two mix minuses that are going on. And when Andrew does a show, sometimes we have 4 people on this show. Each of those 4 people is receiving a separate mix minus. Now, a console like that Mackie can't do that. You'd have to have 4 buses. This is one reason why he's got that little Axia console, because the console is built-in software, and it knows not to send somebody back to themselves if they're remote. If they're in the studio, there's no delay issue, and they can be fed themselves. They're all listening to a mix of the whole show. But people who are remote, where there's a delay built in, you don't want to send them back to themselves, and that's the whole key to mix minus. By the way, mix minuses can get really complicated, like in television, where you've got a lot of different reporters, like at golf coverage. You've got people at all different holes around the golf course reporting in one by one, and sometimes talking to each other. You can't send themselves back to themselves in a situation like that. Or when you've got people at different stadiums around the country, all these remote reporters, that's especially when you have complicated mix-minus setups. So thank goodness
22 of them.
Yeah, there you go. Thank goodness in podcasting, we typically don't have but 1 or 2. But it's key. If you mess it up, you just can't operate hearing yourself back. It's just it really messes up the day. Hey, we're out of time. Chris, you got any last comment you'd like to make? We should continue this at another time, but any last thought for today?
Just a note to self. Echo canceling on voice channels, whether it be Skype, cell phones and stuff, is not a mix minus of any kind. I was working with some podcast folks a couple of months ago, and they were explaining to me how they were trying to use it, and it didn't work. Echo canceling is basically designed so that when you talk on the line, talk on the circuit, you don't hear yourself coming back, so to speak, because it cancels it out. It minimizes the return audio levels, and there's all kinds of things going on. That's the simplest layman's term. So for those of you trying to do podcast, netcast, or anything like, say, JFQ network type stuff, do not confuse echo canceling with any type of minus mixing and all that kind of stuff. Just and Skype does it, and it does it very well depending on the connection, and when it doesn't, that's when you get all those wacky sounds. So just a food for thought. It's also the same on cell phone. When you hear yourself coming back or you're hearing other strange voices, that's when the echo canceling is not working right. But it's not a mix minus, just so you know.
You're right. Echo cancellation, mix minus, 2 different things. Echo cancellation can partially cover up a wrong or lack of mix minus, but if you do mix minus, it's not that complicated. You can do it with a console like that Mackie. Hey, for years we did mix minus on broadcast consoles that you can do it with just a program and an audition bus, or a program bus and a utility or telephone bus. If you see an older console like from the 80s or 90s that says it has a telephone bus, all that is a bus that mixes all the channels together that you want to and doesn't mix the telephone back into it. So it doesn't send the caller back to the caller. That's all a telephone or tel bus is on an older broadcast console. Yeah. So there you go. Hey, we really do got to go. We've taken up a good hour and 15 minutes here. Oops. And I sure thank the chat room for some great questions and topics to suggest we talk about. Chris, I'm sorry, did I interrupt something you were going to say?
Oh, no. You just reminded me that I used to do remote broadcasts, and I would use 2 Shure mixers, and I'd create mix minuses that way with our wireless mic folks at the remote location. So I'd not only have mix minus coming from the studio on the ISDN codec, I'd be creating my own locally for the wireless mics roaming about the event. So you can do it. Just understand the principles, and you're off to the races with no problem. But
And for those of you who
doesn't work.
For those of you who do live sound with a band, isn't there a separate mixer typically for the band, and that mixer is typically up on stage, and you use splitter boxes to take mics and instruments and split them between the monitor mixer and the house mixer. Well, mix minus is not so different from that. A monitor mixer is designed to emphasize certain things for each performer. And so a performer doesn't want to hear maybe somebody else as loud as he's hearing himself. Mix minus is kind of like that. You're providing a custom mix for that remote person. And remember, there's a time delay, whether you're on the phone, on a codec, on a cell phone, whatever it might be, there's a time delay there that you don't want to feed that person back to that person. It's totally confusing. And that's what mix minus is about. Don't feed the remote talent, don't feed their voice back to them. And you've got it covered if you can just remember that. All right, let's thank our sponsor, Telos Systems. Check out the Telos HX6 on the web at telos-systems.com, and you'll find the HX6 there. It's featured, and it's a cool little phone system. I've enjoyed playing with mine. I'm about to do a video about it, a little quick start video, and introduce folks to it. We're shipping it now from Telos. 6 lines, 2 hybrids, no waiting, clear calls. Chris, thanks for joining us. I appreciate you being there. Thanks for your tips.
No problem. Anytime. I'm more than happy to tell people the tips.
And next week, I hope you'll be here for Mike Duro. You think you can?
I will.
All right. Hey, by the way,
if need be, I can always go to the studios if we have to have all the Skypes going.
Well, one thing I should mention, next week, I'm going to be in Riga, Latvia. And so there's a chance that my bandwidth may not be adequate for the show. Plus, it'll be 2 a.m. For me in Riga for the show. There's a chance, Chris, I may ask you to host the show.
No problem. I'll make plans to be ready for that.
If I can make it, I will. If I can't, you demand. But I want to talk to Mike Duro.
Hell, I want to talk. I used all this stuff. I used to talk to him over the years. That's great stuff.
Yeah. That was one of the first processors I ever dealt with. That was a great the DAP. And then the DAP 620s or something.
The 610. The DAP 310 was the original. I had the DAP 310 at several stations with certain modifications. That thing screamed and people couldn't believe it. And then the 610 came out. Unfortunately, it was ahead of its time. I used that too and did make it scream, but it wasn't as easy. But the 310, yes, that's the box. Even today, you could probably make it scream against some of the other stuff.
And Mike has done some other cool things too. We'll talk to him about that.
Oh, yeah.
All right. Hey, thanks very much, Andrew Zarian, for your questions and helpful tips, and the chat room too. Appreciate it. We'll see you next week on This Week in Radio Tech. Bye-bye, everybody.
That's all the bandwidth we can pilfer this week. Another tort has propagated, and all the transmitters and audio equipment live happily ever after, thanks to the handsome engineer and his kind, benevolent care. We'll be back next week.
Lord willing and the creek don't rise.
This Week in Radio Tech. Subscribe to iTunes and you'll never miss a show. Search for This Week in Radio Tech in the iTunes Store. Soliciting is strictly encouraged. If you liked today's show, tell a friend. If you didn't like it, we were never here. Kirk Harnack's wardrobe provided by the Salvation Army and the Red Cross Disaster Relief Services. Hair and makeup provided by Penelope Garcia Hernandez Weinberg.
He's unique, wouldn't you say?
I just want to get it over with.
This ends this transmission. Tango, Whiskey, India, Romeo, Tango. Signing off. Okay.